Hello, human. When someone sees kefir grains for the first time, they often think that gelatinous texture is just shape, something accidental, something that doesn't really matter. But in reality, that structure has a name, a function, and a purpose. It's called kefirin. Kefirin is not a bacterium or a yeast. It's not a residue either. It's a polisacárido, a large molecule made of long chains of sugars, and it's actively produced by certain kefir bacteria as part of their metabolism. In simple terms, kefirin is the material microorganisms use to build their home. That material is what holds bacteria and yeast together inside the grain. Without kefirin, the solid structure of the kefir grain wouldn't exist. The microorganisms would be scattered, and a stable colony would never form. Kefirin doesn't appear by accident. It's produced when bacteria have enough food and the right environment. It's a sign of healthy activity. That's why when kefir grains grow and become firmer, what's really happening is that they're producing more. Kefirin.com. This matrix doesn't just give shape, it protects, organizes, and regulates. Inside the kefirin, microorganisms are more protected from sudden changes in pH, temperature, or environment. That's why kefir grains aren't as fragile as many people think. A big part of their strength comes from kefirin. To truly understand how kefir works, it's not enough to talk about bacteria and yeasts. You have to understand the structure that holds them together. Kefirin serves several functions at the same time. The first is structural. It keeps the colony cohesive and allows it to grow in volume instead of dispersing. When a kefir grain grows or splits, what's really happening is the production and reorganization of kefirin. The second function is protective. Kefirin is part of kefir's biofilm. It acts as a physical and chemical barrier that reduces the impact of external substances. That's why brief exposure to mistakes doesn't always destroy the colony. Kefirin cushions the damage. The third function is functional within the drink itself. During fermentation, part of the kefirin is released into the kefir. This contributes to the slightly thick texture and the mouthfeel. It's not only milk proteins that thicken kefir. Dissolved kefirin plays a role too. This explains why kefir feels different from yogurt, even when both are acidic. Kefirin provides a different kind of viscosity, more elastic and smoother. Additionally, kefirin serves as an anchoring structure for microorganisms. They're not floating randomly, they're organized into layers and zones within the grain. This organization allows different species to cooperate without interfering with each other. When a colony loses its ability to produce kefirin, the grains become small, fragile, or break apart easily. That's not just bad luck, it's a sign of prolonged stress or poor nutrition. Here's the part that ties everything together. Kefirin isn't just important for the grains themselves. It also defines the quality of the kefir. A colony that produces good kefirin is usually more stable, more resilient, and more consistent in its fermentation. That's why not all kefir grains behave the same. Well-fed colonies produce more kefirin. Weakened colonies produce less, and that shows up in their size, texture, and ability to recover after stress. Kefirin also can't be easily forced. It doesn't appear because of rituals or quick tricks. It's the result of a proper environment maintained over time. Good milk, reasonable timing, and stability. Understanding what kefirin is changes how you see kefir grains. You stop thinking of them as loose microorganisms and start seeing them as living architecture. Kefir isn't just fermentation, it's biological construction, and kefirin is the material that holds that construction together. Follow me. I am Kefirin Fermentin.